Trigonometry on the SAT and ACT. It's only a small part of the test, but it's one of the biggest score boosters if you get it right. Today, I'm giving you a full breakdown, formulas, problem types, and test day habits, all in one place. Let's make trig your easiest flex. First things first, the SAT and ACT isn't testing full trig class knowledge. It's testing core identities, right triangle rules, and how well you think with ratios. You don't need to know everything. You just need the right tools, fast. Let's lock in the formulas ACT loves. These pop up over and over again. Right triangle trig, SOHCAHTOA. SOHCAHTOA is your go-to for remembering ratios between sides in a right triangle. As a quick reminder, sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Tangent theta is equal to opposite over adjacent. They'll give you two sides. Ask for an angle, or give you an angle and a side. Ask for the other side. It's plug and play. Just remember what's opposite and adjacent to the given angle. Pythagorean identity. Sine squared x plus cosine squared x is equal to 1. Let's say a problem gives you sine x is equal to 3 over 5 and wants to know what cosine of x is. Now, one way to solve this is by using the Pythagorean theorem, finding what the adjacent side is, and then finding the cosine of x. However, a quicker way might be to use the Pythagorean identity. Instead of drawing a triangle, you can use sine squared x plus cosine squared x is equal to 1. We already know sine x is 3 over 5. So 3 over 5 squared plus cosine squared x is equal to 1. 9 over 25 plus cosine squared of x is equal to 1. Cosine squared x is equal to 1 minus 9 over 25. Cosine squared x is equal to 16 over 25. Therefore, cosine of x is equal to 4 over 5. Law of sines. Sine of a over a is equal to sine of b over b, which is equal to sine of c over c. Let's say you're given this triangle problem. In triangle ABC, angle A is 30 degrees, angle B is 45 degrees, and side A is 10 units. What is the length of side B? This isn't a right triangle, so Pythagoras won't help you. But this is where the law of sines shines. Since sine of A over A is equal to sine of B over B, we plug in sine of 30 over 10 equals sine of 45 over B. 0.5 over 10 is equal to square root of 2 over 2 over B. Now, with a little bit of algebra, we get that B is equal to 10 square root of 2. So just like that, we found the missing side in a non-right triangle using nothing but the law of sines. It's a must-know for the ACT and can help on the SAT, even though it probably won't come out on the test. Law of cosines. C squared is equal to a squared plus b squared minus 2ab times cosine of c. Here's a situation where the law of cosines would work. Triangle ABC has sides a equals 7, b equals 10, and angle c equals 120. What is the length of side C? Well, again, this is also not a right triangle. And since we have two sides and the angle between them, the law of sines won't help here. So what do we use? The law of cosines. C squared is equal to a squared plus b squared minus 2ab times cosine of c. We plug in and get that c squared is equal to 7 squared plus 10 squared minus 2 times 7 times 10 times cosine of 120. Now we compute, we get c is equal to square root of 219, which is around 14.8. The law of sines and cosines look very intimidating, but really it's all about just knowing the formula and plugging in some numbers. Once you understand that, it's really not that difficult. And as a bonus, remember if you're taking the SAT, you probably won't have to worry about it. Radians to degrees. Multiply radians by 180 over pi. If the test tries to stump you with the question, what is the degree measure of 5 pi over 6 radians? First, just convert radians to degrees. Multiply by 180 over pi. The pi's cancel out, and now we just multiply and get 150 degrees. So 5 pi over 6 radians is 150 degrees. Remember this trick anytime you see a pi in the angle. It's a sign you should be thinking in degrees. Now let's go over the most common mistakes and how to avoid them. Mistake 1. Confusing opposite and adjacent. It changes depending on the angle you're looking at. Always reorient based on the given angle. Mistake 2. Forgetting to use degree mode. If your calculator is in radians, your answer will be completely wrong. Always check. ACT problems are in degrees. Overcomplicating simple ratios. If you know the triangle is 3, 4, 5, don't use trig. Just use logic. Mistake 4. Not labeling diagrams. Circle knowns, mark unknowns, write down what you know. Don't work in your head. Now we'll go over habits that'll make your tests a lot easier. Label triangles instantly. Opposite, adjacent, hypotenuse. Write out SOHCAHTOA every time you're stuck. Sketch diagrams even if they don't give one. Use a calculator smartly. Don't type full expressions without breaking them into parts. Memorize sine, cosine, tangent of 30 degrees, 45 degrees, and 60 degrees. It'll save time. Trig is only about 4 to 6 questions max on the ACT, but they're low effort points if you know your stuff. Make a habit of doing 1 to 2 trig questions during every practice session, just enough to keep it fresh. And when you get one wrong, don't just review the solution. Ask, did I pick the wrong angle? Did I forget the triangle rule? Was it a calculator setting problem? With trig, it's about practicing and reviewing until you understand the problems and their applications. If you're taking the SAT or ACT soon, don't stress too much. Focus on taking it one step at a time. You got this, good luck, and if you found this helpful, feel free to check out my other videos here and on my other social media platforms. And don't forget to subscribe.